Hello everyone, my name is Ivan. I'm a programmer in Team 4590 GreenBlitz from Israel. I'm going to do a series of tutorials for programming in C++ for the FRC. We chose C++ because we think it's organized and it gives you more experience as a programmer. So let's start. What we need to do is, this is the Windriver. It's a development environment based on Eclipse, and here we can program a robot to communicate with the serial and also with sensors, give information to motors, everything to program a robot. So we hit new, then example, because we want project from example. Then we choose VxWorks downloadable kernel module, and we choose FRC example of Simple Robot Template. Okay, here it is. So this is our template, and as you can see there is only one file, .cpp here. You can open it. Here is our code. You can see there is the class robot demo. This is the class that represents our robot. You can see here there is an include to a header file called wpilib. This header file contains all the default classes for the sensors, motors, and a bunch of other things. And in Windriver and in WPI, all the source code is open, so you can see it. You can go into the here. We're going to C /Windriver/WPI. Here is hit on the WPI C++. Now WPI, and there is all the classes and the header. Here we can only see the header file. So for example, if we want to see wpilib.h, we hit Ctrl and then click. And here is the wpilib.h. If we want, for example, to see the joystick header file, we hit Ctrl and then same thing, and there it is. Okay, so it's really convenient. Okay, so as you see, our class called robot demo inherits from Simple Robot. Let's see what Simple Robot is. Simple Robot inherits from Robot Base. Robot Base is the base class for the robot. There is Simple Robot Template and also more complex templates that we will discuss about them maybe in the next tutorial. And as you can see, there is few functions here. So there is the robot init, which we don't use it in the Simple Robot, so we don't care now. There is disabled, which is when the robot is not doing anything. Autonomous, when the robot operates by its own code. And operator control, when the robot operates with joystick and buttons. Okay, so we can see here there is the constructor, the autonomous function, and the operator control function that I explained about them. And now we can discuss about the code. So there is robot drive, my robot. So you can see this is a class and this is an instance. My robot is an instance of robot drive. Robot drive is the chassis, which contains two motors. Joystick, we call it stick, and it's the joystick that is connected to the laptop. And now we have here the constructor, and this column represents an initialization list. And we initialize all the class members in the same order that we appeared here. So we initialize my robot with two ports of the motors that the chassis has, and also stick, the port of the stick in the laptop. And here is we call a function of my robot set expiration of 0.1 seconds. This means that when the motors in my robot uh, don't get information for 0.1 seconds, so they just stop. In the autonomous, we have my robot dot set safety enabled false. This means that we don't want to regard this parameter of set expiration. Don't want to regard the expiration time. This is because in autonomous, sometimes we drive with the same speed because we don't have internal loop in this function. This code may be legal. My robots drive this function. You can hit control that you can see what the parameters are. Output magnitude is the power for the driving, and float curve is if you want to turn around. And those values are from -1 to 1. And then we call the function wait, which means that 2 seconds my robot will drive in 0.5 of its power, and then we want to stop it. So if the safety was enabled, so after 0.1 seconds, my robot wouldn't drive anymore because we wouldn't get information for 0.1 seconds. So here we want the safety enabled to be false. And in operator control, we want it to be true because here we have an internal loop, and every 0.005 we get information. And this time is the time that takes the motor to update. So every loop we wait this time, so the motor could get another value. And here what we have is my robot.archdrive. And remember, my robot.drive is first driving by value. Here it takes the joystick and with the values of the joystick. Thank you very much for watching, and we will continue to do much more complex things in the next video.